No matter what style of application you're writing, one of the most common characteristics is the need to deal with data. And it's likely you're going to need to work with an external data source either for reading or persisting data. There's a lot of different types of data sources we encounter, like traditional relational databases, key value data stores, and document storage, just to name a few. And in Where for Dinner, we use two of these types: a relational database like MySQL or Postgres to store searches and availability, and then a key value store like Redis for caching. And in both of these cases, it shouldn't be surprising that Spring has abstraction layers on top of data store implementations. And depending on your needs, it even has a few multiple flavors of abstraction. So we're going to look at parts of Spring's data abstraction using the Spring Data Framework from three perspectives. And those are the data store connection and the configuration that goes along with it, the data objects, which are effectively the POJOs that hold our data, and then lastly, the data access operations. Since the previous video was all about Spring configuration, this is a great segue to examine data store connections and how they get configured. So remember in that video that I mentioned that Spring has an auto configuration feature that will examine your class path, and then it attempts to automatically create beans off of what it finds, and data store connections all fall in that bucket. For example, if you have configuration in your app's class path for a MySQL connection along with a MySQL driver, Spring will automatically create a connection object that attempts to make a connection, and that'll actually manage the lifecycle of that connection object. And as an app developer, you really don't have to worry about all the rest of the underlying details. So what does that configuration actually look like, and how do we actually then go provide it to the app? So first, I want to provide you with a web page that you're going to find yourself coming back to over and over again. And this is the Common Application Properties Reference page, or what used to be called Appendix A. And this has documentation on configuration keys for a lot of the different frameworks supported by Spring. So when configuring relational databases, we use the spring.datasource prefix, and then we'll use the URL field and supply a JDBC compliant URL. You can also supply the username and password and even a database name as separate configuration fields, although you can technically provide them just all of this inside of the JDBC or URL. And these are usually enough just to get your connection up and going. And depending on the Spring data source implementation, you can see there's a bunch of other additional configuration options that you can configure based off of your use case. And the default option in Spring Boot 3 is to use the Hikari data source. So let's go back just a little bit. A few years ago, there's a specification for reactive data sources called R2DBC, which builds on top of the reactive non-blocking programming model. And it's now a first-class citizen inside of Spring. Where for Dinner exclusively uses the reactive model, and we'll get into that a little bit later. But from a configuration perspective for relational databases, there's a little bit different prefix that we use for R2DBC, and that's just spring.r2dbc. It supports a lot of the same fields as spring.datasource, like the connection URL, the username, the password, and the database name. And connections, they're still auto-configured and managed for you, just like using regular data sources. The point here is that if you're using R2DBC, you need to be using the spring.r2dbc fields, and that's the case we're going to find in Where for Dinner. For Redis, there's similar configuration fields under the spring.data.redis prefix, and it has fields similar like host and passwords to configure your connection. And also, just like relational databases, there's additional parameters that you can provide depending on the Redis connection implementation, and there's different ones that you can have on your class path. So now that you have an idea what configuration fields you need to provide, next question is, how do you deliver this configuration to your app? So this goes back to the discussion in the last video that Spring supports a large array of configuration sources, so there's really a lot of options to go do this. A popular option is to use an external configuration source like the Spring Cloud Config Server or the Application Configuration Service. But in a later video, we're going to talk about service bindings, which is an almost magical delivery mechanism supported by platforms like Tanzu. So let's go look at an app, and we'll use the Where for Dinner search service as our guinea pig. So what libraries do we need on our class path? So first we're going to pull in the Spring Boot starter for R2DBC, which will transitively pull in all the other required core libraries. And then next we're going to add in the driver library for each of the databases that we want to support. So for Where for Dinner, it supports MySQL and Postgres. And it also has an option for the H2 in-memory database, which is really useful when you're doing development inside of an IDE. So it actually turns out that if you don't provide a URL in your configuration, Spring Boot will go in and look to see if you have an embedded database like H2 on the class path, and then it's going to use it, which again is really handy for doing development inside of your IDE. But again, when we run our application on Tanzu, we're going to use service bindings, which will dynamically deliver all the necessary connection and configuration data down to our app at runtime. So let's go ahead and run the search application in the IDE, and let's see what happens. I don't have any configuration for database connectivity, so my expectation is that the app will load up using the embedded H2 database. So let's go ahead, and when the app runs, I can look at the logs, and I can see that I found some R2DBC repositories, which basically means it's going to need some type of database connectivity. And I don't see any errors pop up, so I'm going to assume that it connected to the embedded database. And just to prove that that's actually the case, let's go ahead and remove the H2 dependencies from our app. So we'll go ahead and remove these out of our POM, and then we'll try to rerun it. We can see here that when we rerun it, we are getting error messages that there's not a URL defined and that it can't find an embedded database implementation. It actually even goes so far as to give us a hint that we might want to go ahead and add the H2 driver onto our class path. So let's go ahead and put that back in, and that way we can start doing some more development again in our IDE. All right, so this is awesome. Spring's going to handle the life cycle of our data source connections, and that's just, again, one of the things as a developer that we don't really want to have to worry that much about. All right, so the next item of concern is the schema and the POJOs that will define and hold all of our data. For actually creating the tables in the database, we've got some options. And one of the easiest ways to do this is just to create a POJO, and then you can put some appropriate annotations on it. And then Spring has the capability to create all your tables along with all the columns and the data types and indexes, just based off of the POJO and the annotations, and that's all good stuff. Again, this is really easy to do, but personally, I find that it starts to get a little harder and isn't as flexible when you need to do things like making table modifications or doing data migrations. Another option is using a framework like Flyway or Liquibase, which has more managed approaches to schema management, and it also allows you to do some pretty cool things. I found historically, though, that these two technologies don't mesh very easily with R2DBC like they would with JDBC. But that's not to say it won't work, and that's also not to say that it's not going to get easier in the future. And at times, it really is worth the effort to use them together to future-proof your app. However, the option that I've taken in Where for Dinner is to provide SQL files that define the table schemas. And I've created a SQL file for each database that I'm going to support, just because there might be some small differences in each one of these. And Spring knows how to find these files and then do all the database initialization when your app starts up. So you can see in the search application that I've got a table named search, and then I've got a bunch of fields and columns defined for that. And then this table will actually end up getting created the first time that the application runs. So now that our database is ready to go and we've got our tables in there, we need some POJOs, or what are sometimes called entity objects, to hold our data when we access the database. So in the search app, I have a class named search. And you can see here it has the table annotation to indicate that this object is going to be mapped to a database table of the same name. By default, Spring will map the class name to the table name, but you can override this using the name attribute of the table annotation. So inside my POJO, you can see I have instance variables for each field in the database. And similar to the table name, the class variable names will map to field names inside the database. But you can see here that you can override the mapping name using the column annotation. So the cool part of all this is that Spring has everything pretty much that it needs to map data from the database to this class and then vice versa. So we really don't have to worry about writing any type of custom mapping code. All right, so at this point, we have our connection, we have schema, we have the POJOs to hold and map our data. So the final piece of this puzzle is to define the actual operations that read and write data to and from the database. And again, Spring gives us a lot of different levels of abstraction to do this, all the way down to writing database implementation specific SQL if we really want to go that far. My personal favorite, and what's used in Where for Dinner, is using Spring Data repository interfaces. And the main idea behind repositories is to simply define an interface where the method signatures provide sufficient information to discern what database operations need to be executed. And then underneath the covers, Spring handles all the heavy lifting of dynamically creating the queries. And to make things even better, Spring defines some basic interfaces that you can extend that already contain a lot of common methods like read by ID or read all, or even saving or merging entity objects into the database. And then even better than that, Spring automatically detects interfaces that extend these repository-based interfaces, and then it dynamically creates those implementations and then adds those into the application context so you can inject them into your business logic classes. So let's look at the repository interface and Where for Dinner. Generally, you'll create a repository interface per table. So we have one here called Search Repository. And you can see that it extends the Reactive CRUD repository, which is the base interface that defines all of those predefined methods that I just talked about. The base interface takes a couple of parameterized types, which define the type of entity objects that maps into the underlying table, and then the data type of the table's primary key. And then the method names of the interface define custom operations above and beyond what we already get in the base interface. And they use a naming convention which more or less describes the operations that you want to execute. So here we see I have methods named find by name, ignore case, and request subject, and find by request subject, which do exactly what the method names say they do. So I'm going to defer to the Spring Data repository documentation for all the different naming conventions that are available, but I'll just say that they're pretty robust and they cover quite a bit of use cases. So I'm going to assume you probably already noticed that both of these methods return mono and flux objects, which are core constructs in the reactive programming model. So there's advantages to reactive programming, things like optimized resource usage, because non-blocking operations, they get consolidated into a smaller number of threads, and that's just one example of many. And if you want to reap the full benefits of the reactive paradigm, you really need to use it through your entire application stack, which starts with or ends with, depending on your perspective, at the data access layer. It's worth noting that there are base repository interfaces for non-reactive programming when you're using JDBC instead of R2DBC. So just as an FYI, repositories aren't a specific reactive thing. In the non-reactive model, these methods would just return a single search object or like a list of search objects. Okay, so let's see how a repository actually gets used. I mentioned earlier that Spring automatically detects your repositories and makes them available in the application context, which means you can just inject them into other components. And if we look at the search supplier class, which is the class that gathers up all the submitted searches and then it fires them off asynchronously down to the search processor, we see here that at the top that we're injecting an instance of the search repository into this class. And then down here in the supplier function, we're calling the find all method, which is one of those provided methods in the base repository interface. And this method retrieves all of the rows in the search table as a flux of searches. And then we use the filter method on the return flux to remove any unwanted searches. And then we just return back the filtered flux. So let's look at another quick example in the search API class where we're going to retrieve all the searches for a given user. And you can see here we're using our custom repository method find by request subject, and this will return a flux of searches filtered using the user's authorization subject. You also notice that the REST API is defined using the reactive model, which we'll talk about in a later video. But the point being here is that the reactive repository integrates seamlessly with the way that this REST API is defined. And again, you'll get the most benefit from reactive programming if your entire stack is reactive. All right, so I'll stop there on the data access from the relational databases and quickly move over to Redis. One of the cool things about data repository interfaces is that they can be used for other types of data stores like Redis, and you can also use POJOs annotated with the Redis hash for annotating your data objects. So repositories aren't just for relational databases. And just like relational databases, there's also multiple ways you can perform operations on Redis. So in Where for Dinner, we're actually not using repositories for Redis, but instead we're using something called a Redis template object. And because Where for Dinner likes using the reactive paradigm, we're using the reactive version called Reactive Redis template. So Redis templates, they're generic enough to work with pretty much any kind of object as a key and a value. But in some cases, you may have to specifically register a mapping object. But that can be pretty trivial, as you can use built-in string mappers that can match pretty much any type. So in Where for Dinner, we're only storing strings that use strings as keys. So we can use a built-in template called Reactive String Redis template that specifically deals with string objects and string keys. And then even better, when Spring Data Redis is on the class path, Spring automatically creates and manages an instance of this class. So again, we can just inject it wherever we need it without having to do any additional configuration. Oh, and remember, just like data sources, Redis connections are automatically managed for us if we provide our app with the appropriate configuration. It works, just pretty much like the R2DBC connections. So let's take a very quick look at this in action. The search processor service, it has a cache implementation that can use Redis. So here we can inject a Redis template object into our cache class. And similar to repository interfaces, Redis templates come with built-in methods that give us a bunch of out-of-the-box features. So let's look at a couple of examples. Here in the get hash for key function, we're just simply doing a Redis lookup to get a stored string value. And if it can't find anything, we'll just return back an empty string. Another example is where we're doing an add or an update of a string value. And it just simply calls the set method, passing it the key, the value, and then an expiration where Redis will automatically evict it after some time. All right, so let's land this plane. And just like we saw with configuration, this is just all the tip of the iceberg of what you can do with Spring Data. And there's a lot of different options that can be pretty much anything that you want to throw at it. So accessing data sources using Spring Data is just another one of the cornerstones of Spring development. And we'll see in upcoming videos how we'll continue to add additional layers of our application on top of it.